Alright, so today we're going to go over the derivatives for trigonometric functions of trig functions. So I previously sort of introduced derivatives, and we've mostly been dealing with polynomials and those kind of functions, but what about trigonometric functions? So when we talk about trig functions, there's really two main ones. There's the sine function and the cosine function, right? And all of the other functions such as tangent, cotangent, etc. are kind of just derived from sine or cosine. So if we want to find the derivative of any trig function, a good starting point would be to know how the derivative of sine and cosine is. So let's just start with the derivative of the sine function and let's prove it. So let's say we have a function y is equal to sine x, right? We can apply the definition of a derivative, and we know that dy over dx is equal to the limit as h tends to 0 of sine x plus h minus sine x divided by h. Now we know that we can sort of expand this part out through the addition formulas for sine, so that's just the limit as h tends to 0 of sine x times cosine h plus cosine x times sine h minus sine x divided by h. And then if we keep simplifying this, if I take sine x common, I have sine x times cosine h minus 1 plus cosine x times sine h all divided by h, right? And then here I can split this fraction up into sine x times cosine h minus 1 divided by h plus cosine x times sine h over h. And we know from before that, and then all of this is like under the limit as h tends to 0, and so when h tends to 0, this term over here will be 0, and similarly sine x when it goes towards 0 is 0, and we know that cosine x is over here is 1, and then as h tends to 0, sine h over h tends to 1. So then this simplifies out to just 0, and then we get plus cosine x times 1, and then so our answer is just cosine x. So that means the derivative of sine x is just cosine x, and so we found a pretty simple simplification for the derivative of sine x. And now let's go towards the derivative of cosine x. And so now let's say we have a function y is equal to cosine x, and let's proceed pretty similarly for the derivative of the cosine function, and I'll just give it to you. It's just minus sine x. So in short, we have the derivative of sine is, so dy over dx of sine x is equal to cosine x, and then like we sort of derived previously, you can find out that the derivative of cosine x is also simply just minus sine x. And now let's say we wanted to find out what the derivative of tangent is. We do know that tangent of x is equal to sine x over cosine x, and so knowing the derivative of sine and cosine, we can treat this as a division, right? And we can use the division quotient rule to find out the derivative of tan x. And we also know that cotangent is cotangent x is 1 over tangent of x, and so if we know the derivative of tan x, we can similarly just derive the derivative of cotangent x, because that's just tan x to the negative 1. And if you know the chain rule, you can find out the derivative, or you can use the difference rule again. And so you can kind of see how all the other functions, secant, cosecant, as well, you can kind of derive by knowing these two initial properties. And so I'll just give out the formulas here. So in the end, we have the derivative of tangent x. So d over dx of tangent x is equal to secant square x, and then the derivative of cotangent x is equal to minus cosecant square x. The derivative of secant x is equal to secant x times tangent of x, and then the derivative of cosecant of x is equal to minus cosecant x times cotangent x. So yeah, and these are pretty simple to prove, and it's like a good exercise of knowing the product quotient rules. If you do want me to derive them, just let me know. I can derive it in another video, but it'll make this video, I think, unnecessarily long if I were to derive them. So knowing these derivatives, let's kind of do some, I guess, like practice. So if y is equal to secant x, let's find out what y double prime is. So y prime, as we know, is secant x times tangent x, and then y double prime, we're going to use the product rule. So this is simply secant x times the derivative of tangent x, which is secant square x, plus the derivative of secant x is secant x times tangent x, and then times tan x. So in the end, we get y double prime is secant cubed x plus secant x times tan square x. And then I guess for another practice problem, let's just do let's just find the derivative of x squared times sine x, right? So y is equal to x squared times sine x, and let's find the derivative of that. Similarly, we're just going to use the product rule, so 2x times sine x plus x squared, and then we know that the derivative of sine x is just cosine x, and so that is equal to y prime. So pretty simple stuff. The main part about all of this is just remembering all of these formulas, and you should be good.